Welcome to the video on integrals by trigonometric substitution. In this first part, we're going to talk a little bit about why this technique works, and we're going to solve one example. Say that we want to find this integral here. You won't be able to solve this integral using simple u substitution, because here you don't have the variable x in the numerator. So you can use simple u substitution, and you may solve this integral using integration by parts, but it will be a lot of work. So here what we can observe is that the denominator looks like a trig identity, because it is 1 minus x squared. And we have, from trig, we know this identity: cosine squared of t equals 1 minus sine squared of t. And this expression inside the square root looks very much like the right side of this equation. So what we're going to do is to make the substitution: x squared equals sine squared of t. If x squared equals this, x should equal the square root of this, that's sine of t. And to make the substitution in the integral, we need to find the x also. And to do that, we find the derivative of x with respect to t, that's dx dt, and that would be the derivative of sine of t, that's cosine of t. That means that dx is cosine of t dt. Now we are ready to make the substitution. X equals sine of t, dx equals cosine of t dt. So we make the substitution in the integral. Here dx becomes cosine of t dt, and x squared becomes sine squared of t. But here we can use the trig identity we just saw. This will be cosine of t. So here cosine of t cancels, and we get the integral of the t, that's just t. Are we done? Not yet, because our integral is in terms of x, and we got our answer in terms of t. So we should substitute back t. We know that x equals sine of t, and that means that t should equal the arcsine of x. That's the inverse trig function. So here we're replacing our answer to get that this integral equals arcsine of x plus c. That's the answer. So why this substitution works? Trigonometric substitution allows us to simplify radicals, because we have these identities. We have this first identity that we used in our previous example, and we also have this other identity. For example, in our example, we had this expression inside a square root. So using this identity, what we can do is to simplify the square root, and can also do something similar with this other expression here. For example, when you have an expression of this form, a squared minus x squared, where a is a constant, you should use a substitution: x equals a sine of t. And if you do that, you will get a squared minus a squared sine squared of t. You can write this as this, factoring the a squared, and this equals a squared cosine squared of t. Doing this substitution will allow you to simplify many things. And when you have an expression of this form, a squared plus x squared, you should use this substitution to try to use this other identity here. Because if you use x equals a times tangent of t, you get this expression, and using this identity, that should equal a squared secant square of t. When you have a difference like this, you use x equals a secant of t, and you use this identity, but here you get secant square of t minus 1, and using again this identity, that equals a squared tangent square of t. So these are the trig substitutions that will be useful to you, and in the next videos we're going to solve more examples using these substitutions. That's all for now. Thank you for watching, and see you next time.